Okay, so good evening. I am Cédric Hervet, and I will talk about optimizing last mile operations in real time, as well as stuff about AI and about augmented humans by AI, and how we try to achieve it in our daily routine. So I own a PhD in applied mathematics and with a specialization in combinatorial optimization, which is also known as operations research, which is really the science, the mathematics of optimizing complex stuff like factory scheduling and obviously last mile optimization. I was in charge of the research and development teams in several marketing automation software companies in which I tried to implement some data science strategies and optimization algorithm in order to deliver a greater output to what they were doing. And I co-founded Citodi in 2015 with Jonathan Boaziz, which is in the room, hopefully. Okay, so what is Citodi? This is an artificial intelligence, and I will try to put some more concrete words behind what AI means for us. And what we're trying to do is to optimize the last mile deliveries in real time. What do I mean by that? Here you've got an example of a map with some stops that are scattered across the map, and you want to deliver all these stops with the best operational efficiency. So here we have two drivers that we want to dispatch on all these stops. They are coming out of the center point, which is a depot. This is an example among many concrete examples we can encounter in with our clients. And here we have to design the best way to visit all these points with two drivers. And you want to do this at the lowest cost possible. And this may be simple on this small example, but it's actually one of the hardest mathematical problems ever. And this can be shown by all the complexity studies behind it. So it's really hard to do at all, and it's even harder in real time. So I will talk about this more later, but before that, I want to talk about a little bit about what is AI. And actually, instead of telling you what is AI, because AI can be many things, I'd more try to tell you, from my point of view, what does an AI, which is quite different from what it is. If we try to make some analogies with what humans are doing, I would sum up what an AI can do by three things. It's perception, understanding what you've been perceiving, and then taking actions, taking decisions according to what you've understood previously. So there are many technologies linked to each of these steps. In most AI applications, you will encounter the two first steps are the most used. And on my side, I'm more specialized in the last one with operations research. It's really the science, teaching machine to decide, teaching machines to make the best decisions. So you probably heard of all these technologies, and we are really focused here on the last part. For the decision part, because you've all heard about what AI can do to recognize what is if there's a dog in an image, to understand the natural language via NLP and everything. But making an AI take good decision is something that is not natural for a computer, and you really need to teach it how to do it. And there are really decisions that we humans are very comfortable with. We are very intuitively taking the best decisions every day, and there are other types of decisions that are better suited for a machine. And I'm telling you this because it's really important to draw a very clear line between what the machine is good at and what a human is good at in order to separate both when you're trying to implement AI on a field. So just a quick example, what's easy for us and easy for a machine, it's to make a simple choice between a few alternatives. You want to buy the cheapest smartphone that you have in front of you. Okay, it's really easy. You just read the price, you pick the cheapest. A machine can do this as easily as you. When it gets hard for us, it's really when you've got a lot of computation to do. If you try to compute just by mental calculus the total revenue of all your retail shops all around the world, it's really something impossible for you. You can keep track of the calculus because we are not just made for that, and a machine can do that very easily. What we're good at, on the contrary, is to adapt, to define strategies, to raise questions that we've never encountered before in front of a new situation. And machines are not just good for that, they're really good at doing what they've been programmed to, okay? So yeah, we can talk about this later. What's interesting for us, it's the nearly impossible for us and hard for a machine, real-life NP-hard problems. It's a very specific class of mathematical problems that are combinatorial in their structure. That is, there is so many solutions, and it's growing so fast that a human can very fast not handle it at all. And even for a machine, it's really difficult. You need to design some very powerful algorithms in order to handle that kind of problems. And for the nearly impossible for both of us, I mean, it's something I won't cover here, but it's very difficult problem. So yeah, what are we good at? What are the machine good at? For a human, what we are good at is defining strategies. In front of a new situation, what would be the best way to handle all the specific, sometimes obvious criterion you can handle on something, and some are more subtle, more unconscious. When you are especially dealing with some customers, there are some gut feeling about what you should do in some situations, and we are really good at it. On the opposite, the machine is just good at computing complex and large stuff very fast. This is all a machine can do. Even if you might read in some general media publications, stuff about AI, I don't know, modifying its own code, fooling its conceptor, it's almost Skynet in the media sometimes. No, actually the machine is just doing what she's been programmed to, and she's doing it more efficiently than us because she's just good at computing. In terms of business, what does it mean? It means really that a specific aspect of business, that is quality of service, is really something that should not be left to machine alone. That does not mean you don't want to use a machine for quality of service, but you should not leave it to the machine alone. In the case of last mile deliveries, the biggest pain point in terms of quality of service is really being on time when you try to deliver some goods. You've all been upset, I guess, about waiting your parcel in the morning, and then the guy just show up at the end of the afternoon, or if he shows up at all, and then you're just not home anymore, and it's really boring. So yeah, the quality of service in parcel delivery is really about being on time at the customer, but it's something a human can really easily overcome with a very nice smile and very sincere apologies from your driver, which seemed to be a very nice guy. He's late, but he seems so sincerely upset and sincerely sorry for what you've been imposing on you. You might forget that he's actually late, and you might even give him a good grade. On the opposite, if you have a powerful machine for computing delivery routes that are on time at every customer, but your drivers are just being rude at everyone, almost insulting them if they're just but they don't say hello and anything, your customer experience will be very bad, even though the guy was on time. So never put the human out of what you're doing on the field. Just use AI as a support, and that's why I'll try to demonstrate how we are trying to achieve it at Citodi. So last mile optimization, I told you earlier that it's a nearly impossible problem for us and a very hard problem for machines, and it's really linked to the combinatorial structure of this problem. Just a quick example, if you have 10 stops to visit and you want to find the best way to visit all these 10 stops, you can compute all the possible solutions in less than a second and then pick the best one. You just add 5 more stops, you've got 12 hours of computation. Even with a big computer, you just add 5 more stops, you've got 2,000 years of computation ahead of you just to find the best way to visit these 20 points. So you won't be on time, definitely. And if you add more points, with something like 60 points, you just have as many routes as there are atoms in the whole universe. So it's just not computable at all. So yeah, and in the real life, you do not have 60 points. You will have thousands of stops to consider. You will have several drivers with their own working time, with their own vehicles, with their own capacities, with their own speeds. You will have time windows at each stop that you need to respect, and you will also have 1 second in real time to solve it. So it's quite a hard problem to solve, actually. And it works. It works very well when we are trying to apply some operations research technique to this kind of problem. The gap between what a human can perform on this is really huge, and it's really not because we are bad at it, it's just because the problem is so difficult for a human mind that the algorithm will try to gain, if you speak in terms of kilometers, it will gain just by finding the right permutation on the whole route, the permutation that earn you 1 kilometer, and 1 kilometer per 1 kilometer, it will make something like between 15 and 40%. It's also true in terms of operational cost, in terms of CO2 expenditures, and everything. So there's a huge gain in trying to implement this kind of technology on the field, but it's also very problematic because there are many things that can actually happen on the field, and the main reason why people who are trying to do this for many years now and not trying to put it on the field is because the nice routes you compute yesterday for today, actually they will encounter many problems, and these problems are well known. It's the traffic, it's clients that cancel, that are not home, anything that can put your nice plan down to the ground because there are some events that you cannot anticipate. So you need to be able to react to this kind of to problem in order to adapt your routes. So that's why we are proposing an event-responsive framework to solve this problem. We are doing optimization of the routes, obviously in advance, before the day actually occur. But when the routes are actually taking place, when people are on the field visiting the various stops, we will also be able to take into account many events, many real-life events that occur every day, every second on the field. Those will be obviously traffic changes. The Parisian peripheric is known for that. So yeah, many things can occur, and the distance from A to B, the duration from point A to B may vary from 1 to 3 times the actual the standard time to perform that distance. And we can handle many other events, like the customer that cancel his delivery. He wants to modify his time window. I wanted you to deliver me on the morning, but actually I'd rather have it at 12. Address modification, deliver me at work instead of at home. The driver, obviously all the events that are related to the driver himself, if he's late, if he's in advance, it's really important to exploit every second you can get or what you loses in order to adapt your route in real time, in order to be on time at every home. Obviously new orders, very important for all the same day deliveries stakes that you can have today, and obviously some other scenarios like vehicle failure. That is the most complex scenario we can handle, where a vehicle with parcels in the trunk just fails in the town. He automatically become a new pickup point for other drivers that are rerouted towards this pickup point in order to deliver the goods in due time, even if the driver was encountering failure. So this is what we are doing. But actually, we are proposing this as an application, as something in the hand of the driver, so it can help him taking the best decision on the field. But as I said before, this is a very hard problem for a human to solve. So we can just tell him, okay, these are all the distances, all the duration between all the points and all the customers you have to deliver. He won't be able to design on its own a nice route. So we have to propose him with a clearly optimized route. But if we do this, we remove from him all the expertise he may have. We remove from him all the decision, actually. And this is not at all the augmented human paradigm that we want to achieve when we do AI. We want an AI that is supportive of the driver in order to help him perform better, but we don't want to remove from him his decision capacity. But I also said that we are gaining 15 to 40% from the human. So you might say, okay, why not let the AI decide? It may not be ethical, but it's clearly more efficient. But actually, it's not. Because on the field, there are many examples of the driver being more clever than the machine. And if you robotize the driver, you will lose all the benefits of having someone smart on the field taking very good local decisions. Here is an example of a route. You have several pickup points or delivery points in this map. You've got the ETAs displayed. That is the estimated time of arrivals. And this is a very nice route, very optimal. You don't make any detour. It's probably the best way to achieve the visit of this point. But when you show this to a driver, he will tell you, okay, here there is a primary school, okay, and you're telling me that I will have to make a delivery at 16:48 when all parents are parked in the street. So I won't be able to park, and you want me to deliver something at this time. It will tell you, I just can't do that. And the machine won't be able to know that either. For those here who do AI, I mean, collecting the data in order to be able to anticipate that specific point, and this is only one use case out of thousands, it's really impossible. Therefore, and in addition, it would be not very smart to spend a lot of resources and money in trying to handle that kind of specific use case, while you have someone knowing it perfectly that can actually handle the problem immediately, which is the driver, which is a human. So we do not want to remove the capacity of the driver to improvise, to take smart decisions locally. We just need to be supportive of him, even when he will make different decisions from what we've been suggesting to him. So our solution and our way to do AI as an augmenting AI on the field is to do like this. We consider the driver's input as an event, as well as traffic changes, as well as new order coming in. And when the driver decides to do otherwise, we just take that as an input and we adapt our routes to what has been decided. So concretely, that can take that form. Here's a simple application where the driver can visualize his route. So there is a sequence of stops he will have to visit. The first stop is the one we are recommending to him. He should go there, but then he chooses to go elsewhere. Then there are some computation running, and we can tell him, okay, you can do that. There is no impact on the route. You won't be late anywhere, and if you think it's a better idea, you could do that. Here, he just cancelled. He's trying to do something else than what we've been suggesting to him. And then, oh, okay, there's a warning. If you do that, we can mathematically prove that there is no way you will be on time at every time, and actually the cost for you will be being late at one stop. And if you take that decision, it will be impossible to make it either. Then we are pushing the strengths of the mathematical proof to him in order to show him that he will make a bad decision. After that, he can still make that decision consciously if he really thinks that there is no other choice for some reasons he may have. He's still autonomous. That kind of application have been pushed on the field in the hands of expert drivers with excellent feedbacks from them. Actually, it's not an application that is robotizing them. It's not their new boss. It's just something that really helps them on the field. It keeps tracks of everything, and it will especially not forget everything. Here, it's classic delivery route. You've got 60 to 100 points to deliver during the day, and it's probably one stop every 3 minutes. So it's very intense. It's really fast, and the driver does not have time to spend time. He does not have the time to spend to think about what is the right way to do his tour. So he really needed to be efficient, and sometimes he will forget Madame Michu, who has to be delivered before 10, and if it's not in his mind, he might forget it. With this algorithm, he never forgets. The algorithm will push it, Madame Michu, back to the beginning until he delivers him. So it's really a gain of fiability for them, a gain of robustness in how they handle their routes, and in the end, it's a gain in terms of quality of service, really for them as well. And so the feedback we had were excellent. It's really we are really trying to achieve the augmented driver paradigm here with this simple example. Obviously, you can add even more features, like, okay, I'm stuck in something like traffic congestion. What would be a better alternative from what I've done? Okay, I turned in the wrong street, so find me a better alternative. You can really help him on the field finding better ways to modify his route. So this was my example. As a finishing word, I would say that for us, what we're trying to achieve with an AI that is potentially capable of taking decision in place of a human, because we are actually taking potentially better decision, a much better decision, as I said before, because plus 15, plus 40% in terms of personal cost is huge. But if you completely remove the human from the whole process, you might lose on the other side, that is quality of service, that is local smart decision a human can make. So actually for us, building an efficient AI is really drawing the right line between what the machine is good at, which is computing complex stuff and large stuff at a very fast pace. That is what machine is good for. But actually, we're trying not to remove the human from the process, because actually it can really help the machine taking good decisions very locally as well. That is all for me. Thank you very much.
Thank you.
If you have any questions.
Well, I have a naive question. Basically, Cédric, do you have in the field of your business, when you take the old school companies like DHL and all this kind of company, and in the other hand you have the new startups like Deliveroo and Foodora, and they're probably working on that stuff. How the AI is disrupting the way of creating value for this kind of people? Well,
for the legacy delivery companies, for a long time they've been tackling the problem differently, not by algorithms, but by organizing their depot, their location, their how the parcels to driver allocation was. It was systematical. So they somehow built a little bit robust system that was fixed. It was not moving at all. It was not adapting itself to any of the changes. So for them, it's really it gives them the capacity to say to their drivers, okay, yesterday you came to that city to your deliveries. Today the optimal decision is to go this other way. And they are moving from a very routine work to something more changing and more adaptable to the seasonality and all that stuff. And for other companies like Deliveroo, actually they are not really needing that kind of technology, because when you are Deliveroo, you are just delivering maybe 2, 3, 4 meals at most. So in terms of optimization, it's quite obvious. A human can handle it, but I know that they have some algorithms behind it in order to wait the right moment to send a driver, depending on the seasonality, the demand. So the problem here is more about waiting the right time to send a driver, so he can depart with as many meals in his bag as possible, in order to reduce the overall cost. But it's less about optimizing the sequence of points. That point is easy. It's really the waiting time that is the core problem here. Okay. Any question? Yes, please. Lisa, juste devant.
It's a question as a follow-on question to what Kamel asked. Who are your customers, whether you have current customers, and what are the use cases or groups of use cases?
Okay, so there are two main types of customer. They are the delivery companies, so logistic, delivering huge number of parcels every day. So for them, it's really something that we will implement at the core of their business management operations. And on the other side, there are some field services companies. So they are not delivering goods. They are traveling to perform some interventions, maintenance. They will, I don't know, your plumber may have some routes. So these kind of people will have good use of it. The main difference between the two is that for logistic companies, the volumes, the size of the problems we are trying to handle is very, very large. And for the field services companies, it's more like they will have some weird constraints. For the plumber, for example, he needs to go back to his central depot in order to pick up some new tools and everything. So it's really that kind of difference we will have between the both.
Yes. Compared to other existing solutions on the market, how does your solution perform? Or have you made any tests comparing all the systems? Because it looks very attractive, but at the same time I say, well, okay, how better than the others is it?
Well, it's really hard to to ask them to compare ourselves. So what I can say comes from what we've been doing in RFPs. In all our recent RFPs we've been undergoing, we came first in terms of performance. So I don't know how far we are from the other, but we know we're the first on the small RFPs we've been doing. So that is the first thing. And really, the two main differentiators we may have is on the scalability. There are not many companies that are able to handle tens of thousands of points in less than an hour. So this is really something difficult to do. And the other thing is the real-time optimization. The best of my knowledge, we're the only ones providing this kind of so much integrated, real-life events handling. So.
Yeah, please.
Great presentation. A quick clarification. Do you provide the backend, which your customers build on as a front end, or did I get that wrong?
For now, we're just providing APIs mostly,
Okay.
but yeah, we're working on providing all the other things that you proposed as a platform for other customers. Yeah.
Okay. And a more general question then. So, as far as the optimization problem is concerned, do you see more value, based on the presentation, in, let's say, a local problem solution, let's say routes up to a few hours, or more, let's say, a larger scale, so hours to days?
Well, the example I showed you was really, it was just a focus on the specific time on the day. Actually, we're doing optimization at a daily scale. Sometimes a week scale for longer routes where the drivers need to go 100 kilometers away from their depot in order to do some stuff and then coming back. So we also handle some the cost of overnight shifts and everything. So yeah, it's large scale. The larger the scale, the better actually for optimization. We are also breaking the frontiers in terms of geographical separation. Most of the time, the logisticians tends to split the geography in terms of a depot handles that area and everything. We can remove these barriers in order to have a global optimization as well. So this helps a lot reducing costs.
Do you see the added value more in the global, like the bigger scale that you mentioned, or the local part?
No, in the bigger scale.
Oh,
yeah.
Cool. Thank you.
I have a last question, perhaps. How do you make the difference between when a guy decided not to get your pass and to change because he wants to grab something to eat and something personal, not just about the optimization, about your example, how the AI can learn that it's not about optimization, it's about something like doesn't connect, you see what I mean?
Well, it's actually the tricky part because in order to understand why the human is doing this, you probably need to get him tell you what has been happening. So we're trying to implement some kind of structured data collection, just asking him, okay, you want to modify this, do you have a reason? Pick one out of many, for example. This could be a way to understand and to gather some structured data in order to treat him better later on. But the other way will be also by KPIs. You can compute if a driver and one driver out of the others is really always changing what the algorithm is proposing, it's probably that there's a problem as well. So extreme behaviors will be tracked in order to okay, maybe there's something weird, he's not trusting the algorithm. It may not be for bad reasons, but we need to understand why, at least.
Perfect. Thank you, Cédric.